My name is Robert Clark, and I'm a public health student at the University of Arizona, and I've been working with Dr. Heidi Brown in the Epi and Biostats division on a descriptive analysis of the temporal and spatial stability of rabies in Pima County over 7 years, 2004 to 2010. So just the research questions that I'm focusing on in the study are: what is the spatial distribution of rabies by zip code in Pima County? What are considered hotspots according to Getty's ORD, which is the calculation that we use and I'll explain later. And according to the data, what month is the most risky for rabies exposure? And then we're also looking at species stability over the 7 years. So just the study area, we're looking obviously here in Pima County, which is located in southern Arizona. And rabies has been recognized here since the 1980s. Tucson is the metropolitan city, the epicenter of the county, with a population of around 990,000. And aside from Tucson, Pima is mostly a rural desert. And major washes throughout the county include the Relito and Santa Cruz River, which I will explain later their significance. Animal data that we're looking at. Confirmed rabies case definition is any animal that has been tested positive for the rabies virus that has tested positive through a culture by direct fluorescent antibody test, and they take a specimen of the brain and then they test the central nervous system, so the animal must be dead to check for rabies. And then all of these specimens are collected and submitted to the Arizona State Lab in Phoenix and other neighboring facilities in Nevada and Colorado. Then each of the counties reports back to the state, and then that's how we have our data. The current data components that I'm looking at are information from the Arizona State Lab, and it looks at the type of animal species, the geographic location, like pickup of the animal, whether there was animal or human exposure except for 2 years, and the date. And we're also looking at zip codes because I need to fulfill a certain N value for the Getty's ORD stat that we used. So zip codes fulfills that with 51 zip codes in Pima County. With the data analysis of this paper, we looked at incidence, which is the frequency of rabies cases by population. We used the Census 2010 data. Because the actual number of wild animals could not be collected for each zip code, we used human population as our denominator to calculate the incidence. And then also just human population is a good way to standardize the data, as most collected animals were called to Pima Animal Control. In addition to the descriptive stats of incidence, we calculated a species stability based on a work from Roberto Barrera, what he did with Aedes aegypti mosquitoes and their stabilization. We just kind of mimic that with rabies. With the GIS, it's an mapping software. We were able to map rabies across the county and use the hotspot analysis tool, which is kind of how you conduct the Getty's ORD local statistic. And this metric identifies spatial clustering of high or low values based on their neighboring features. We're also looking at linear regression analysis, and because the frequency of rabies cases has an inverse normal distribution, we have to use the Poisson regression, and I'm still developing that, so that's kind of blurry. And we're also looking at time series, so just over time, what rabies looks like. So here's a map of all positive rabies cases from 2004 to 2010. As you can see, this is a zoomed out view. There's a couple cases of bobcat and javelina in the area, but I'm mostly looking at metro. So I just highlighted bat and skunk because that's the majority of cases. And then also with the major washes, we're looking at the distance to wash calculation, which would tell us if there's a prevalence among washes. So that's why I identified those washes in the beginning, because you can't really see it because of the bats kind of overpopulating, but there's a lot of cases along the Relito. So that would be something that we could look at. This map is the frequency of rabies cases by zip code. So as you can see, the darker areas have a higher frequency of cases compared to the white, which is completely zero, and then the lighter areas are lower frequency. So areas to look at, this one right here is 85704, so that's Northwest Tucson. There's a high frequency of cases, and then also all of Eastern Tucson. And that's kind of Green Valley area, so that's something to look at. The next map is incidence. So this is the frequency again over the population. So because Arivaca at the bottom has a lower densely populated area, but there's more cases, the incident rate will be higher, as well as Mount Lemmon. Just because the population of Mount Lemmon is low and there's a higher frequency, the incidence goes up. So this is looking at the time series. This is the positive rabies cases by month. So this is the sum of all years. And as you can see, skunks are kind of like in the winter and spring months, and then there's kind of like this, the bats follow the migration patterns. They come in April, and then there's a huge spike in September. So that's why we would say from this that September is probably the riskiest month of exposure to bats in Pima County. So this is the species stability along with just the distribution of species across all years. So on the y-axis is the number of positive cases, and then x is the year. So just looking at this, you can see that bats kind of dominated most of the year. 2005 and 2009 were peak years for skunk exposure. And then just the correlation looks at the stabilization of species across years. So it's pretty much significant all through 2004 to 2010. So just in the discussion, we're looking at just distribution of cases across zip codes. Then we can identify the hotspot area, which right now is Mount Lemmon, just because low population, high number of cases. But we're also looking at Eastern Tucson to develop the education in those areas. We're also looking at the cost effectiveness of PEP, which is post-exposure prophylaxis. Currently, most insurances do cover it, but if you're looking mostly at $1,100 for the 4 doses and then the 1 dose of the human rabies immunoglobulin. So just to think that even if a child comes in contact with a rabies case, sometimes the case is untestable, or it's just the timing of the testing. It usually takes 2 weeks. So just that timing of waiting to see if they should get the PEP or not, as a precaution, the county usually just recommends that you get it. So that's $1,100 for each exposure. So that's why we're looking at cost effectiveness. We're also describing the mapping pros and cons, just looking at, is it helpful? What if there's gaps in the data? That's not gonna help. Like I said, there's low frequency in areas where the population is 0, so we're looking at the cons as well. And then also just the effectiveness of the current rabies control and prevention programs here. Sorry, this was programs. And then at the end of my discussion, I'll be giving recommendations back to the county of what they can do to improve their current surveillance. So then I would develop a curriculum with them for rabies prevention implementation within school settings of those hotspot areas. And then also what they can do to improve the rabies collections, maybe start getting photos of the actual animal that will help identify the species variant, which then helps us further along with our investigation. Bless you. And also maybe possibly have like a new database where they just, that's where they put no paper logs anymore, just a centralized folder of all cases, which then will help, in the end, help them. And then further we can then start researching why certain species are here in the county. Like, why is there a spike in bats? Obviously I can't do that over this period, but maybe it's something I can do with them in the future. So just acknowledgements and any questions you can direct to my email.